In this lecture, you will learn about additive manufacturing technology for polymer material industrial application sector. After this lecture, you will be able to describe technology for polymeric material with a line of key industrial sector for the application of polymer EM. What is polymer-based additive manufacturing technology? With the attention of 3D printing and additive manufacturing reserves, it's often difficult to believe the technology is actually 30 years old. Chuck Hull, the father of 3D printing, then known as stereolithography, developed the idea while he was using UV light to harden tabletop coatings. Today, polymer-based EM is a rapidly evolving world in which designers and engineers are pushing the limits of material and technology. Several polymer-based EM processes are currently available commercially: VAT photopolymerization, selective laser sintering, material extrusion, binder jetting, and material jetting. Polymers surpass all other materials categories in terms of materials used per year. Polymers include thermoplastics, thermosets, elastomers, hydrogel, polymer blends, biological systems, and other polymer-based composites. Material can be selected based on properties such as transparency, color, tensile stress, rigidity, biocompatibility, glass transition temperature, and so on. Materials are available in a variety of hardness that range from very hard to rubber-like elastomers. But there is more that can be done with 3D printed material to make them more flexible and more useful. You can do structure that can transform in a pre-programmed way in response to a stimulus. This is 4D printing, a new process for printing customizable smart material developed as a collaboration between the Self-Assembly Lab, Stratasys, and Autodesk. 4D printing is the process through which a 3D printed object transforms itself into another structure over the influx of external energy input, as a temperature, light, or other environmental stimuli. The 4 basic steps in polymer-based additive manufacturing include virtual modeling, machine preparation, material processing, and post-processing procedure. A 3D model is the virtual input that a 3D printer needs to print an object. It is possible to get a 3D file by dissolving heat. There are many sites out there that offer tens of thousands of 3D files. 3D scanning an object, or design it with 3D modeling software. Once data of the model is being processed, machine preparation takes place before printing the actual object. This process may involve its processing of the polymer, preheating the design space to working temperature, and calibration. Additionally, quality checks are done to identify errors before the actual object building. Machine preparation is a vital part of additive manufacture as it can determine the quality and accuracy of the final product. The additive machine then builds the object by editing the polymer layer by layer. There are various methods of processing applied when building an object. Its processing involves melting the polymer partially or fully, using laser or conventional heat source, and then cooling the formed physical object. On the other hand, light processing using the liquid photopolymer is used to initiate a chemical reaction within polymers, creating new chemical bonds which solidify to create the object. Since bending the polymers involves its process, the object is allowed to cool. Post-processing involves cleaning to remove excessive polymer, removing substructure, possible post-cured in UV oven for fat polymerization technology, honing, grinding, and cutting. Additionally, painting and polish are typically done to improve the appearance of the object. Additive manufacturing has the potential to revolutionize the organization of all the activities carried out by far. The growing diffusion of this technology is increasingly changing small and medium farms to reinvent their business models. These technologies was initially used by companies for prototype purpose for decades. Today, EM technologies have numerous applications spanning various industries: automotive, aerospace, healthcare, defense, energy, behavioral architecture, fashion, art, and food. Aerospace companies were some of the first to adapt additive manufacturing. Less material consolidated design resulting in overall weight reduction, one of the most important factors in manufacturing for space. The rapidly innovating medical industry is utilizing additive manufacturing solutions to deliver breakthrough to doctors, patients, and research institutions. Some applications for the medical industry are orthopedic implant device, dental device, pre-surgical model from CT scan, customer saw and drill guides, enclosures, and specialized instrumentation. HEM technology have helped automotive suppliers and companies develop consolidate lightweight components that lead to more efficient vehicles. Some of the applications that have transformed the industry include complex ductwork, resilient prototype, elastomeric models, grille, custom interior features, and large paneling. The market is segmented geographically into North America, Latin America, Europe, Asia Pacific, and Middle East and Africa. Explosive growth in the field of EM has created many new opportunities in manufacturing during the past 2 decades. Applications of EM technologies are evolving and expanding, and some have yet to be imagined.